Thank you, Neil, and thank you, New Relic, for inviting us along to talk about scaling peak load. So, who am I? Obviously, why do you want to listen to me speak? I'm Morgan Atkins. I'm one of the DevOps and continuous delivery consultants at ECS Digital. I've been in the industry almost 3 years, so I'm pretty young, but I've been to some of the big players in the industry, right? With the help of ECS Digital, I've seen large banks, I've seen gas and electric, I've seen telecoms, I've seen startups that go from 5 people in a room to getting their first funding round of 200 million for an idea, and I've been part of the teams that help kind of build applications at scale. So there's some of the background of ECS and ECS Digital. Obviously, we are a large consultancy. We are based in London primarily, but we have offices all over the world. Collectively, we have, I think now, 15 years of experience in kind of the DevOps and automation space, as well as obviously our enterprise knowledge. Quick rundown of the agenda of what we're going to talk about. Obviously, I can't say I've got as many football references in my presentation as Neil did, but we're going to run through why you want to engineer for scale, and kind of looking at the impact of not being ready. We're going to look at some ways in which you can build for scale, explore some of the success factors. So we're kind of looking at obviously the cloud migration path and containerization, and then we're going to have a brief look to the future. So where is this technology going next? Obviously, a lot of you are on or starting your journey to the cloud. But what happens in 5 and 10 years' time when you're in the cloud and you now want to optimize and go to the next place? Where all the startups have already been, and you now need to take your organizations to next. So why? Obviously, we've already heard some stories around kind of peak load, but have you ever experienced, so who's been to Glastonbury? Nobody? I haven't been myself, but there's a few, and obviously you may have heard it in the news when Glastonbury goes live and they put their website up to say, look, the tickets are available, it often crashes. The amount of load that they see in a day, some websites might never see in a lifetime. Things like secret sale drops. So there's a few guys in our offices, if you're not aware of this kind of phenomenon, it's kind of growing in the trainer industry, so the sneakers and trainers. People like Nike and Adidas will put a secret announcement out on the internet to people in the know and say, look, we're going to sell a rare trainer. Be on our website at midnight, and there'll be 500 pairs available for you to buy. Now, I've watched some of the guys in the office do it, and they're there with their iPad, their phone, their laptop, trying to buy these trainers because apparently they're amazing. I can't see it myself. But again, the same sort of thing happens. There is a massive peak in load. The website's not prepared, and they're waiting 20, 30 minutes just to get a order confirmation. That's a similar sort of trend. Has anyone heard of the hug of death? Cuddle of death. So some of you are aware of it. So if your website is mentioned on, say, Hacker News or the front page of Reddit, you're going to get hundreds of thousands of genuine clicks to your website that you're just not prepared for. It's not a denial of service attack, but it looks like one. So these are the kind of things we're looking to scale for. How do we react? If it's not a Black Friday sale where we know the traffic's going to be coming, it's a random event that happens outside of the organization that is causing this to happen. And of course, then there's compliance. So like I said, I've worked in banks, retail, and B2B. I've worked in gas and electric. They have to show data to their customers and to other businesses about their annual forecasts. And the way they do it now is host a website. But that website has to be up 100% of the time. They can't afford for it to go down because that will give a competitor or people who are consuming this data a competitive advantage over somebody else. And basically, you don't want this to happen, right? You don't want your customer to go to your website and get a 500 error or just absolutely fail out and not be able to serve your content, because that has a has an impact on not only obviously your product line or your services, but your reputation. And ultimately, that's what we're trying to protect, is the reputation of an organization. So obviously I highlighted some of them already, but some of the problems of the past, applications and operations teams that maybe aren't designed for peak load, and operations teams that just aren't ready for the kind of traffic that we're seeing these days. Obviously, millennials and young people who are constantly on the internet, they're constantly on Reddit and Facebook and constantly consuming data, and it's the only way they kind of interact with the wider world. So problems before would be, you maybe over provision something. So you deploy your application, you decide, look, we're going to, based on the information that we have, we think we're going to get 100,000 hits an hour. So you'd build an estate or a temporary application state that is massive, and then you don't get that sort of load. That's a waste of money. It's a waste of everybody's time, and it's underutilized. And obviously, then the reverse is true. You can under provision and then just not be ready. And obviously, then the metrics that you're traditionally collecting just don't give you the awareness you need, and it's that awareness that's key to building a successful application and to building a service that people want to consume and can consume whenever they want to. Okay, so in my experience and the experience of kind of ECS and ECS Digital, there are three main areas you need to be focusing on. So obviously that's awareness, that's your monitoring, that's your your user experience. What kind of metrics, what kind of metadata can you collect about the users and your application? Availability, obviously you want 100% availability if you can, but realistically that's not going to happen. So you need to build in countermeasures to be able to react to peak load, and when you're not available, what do you do? And obviously then there's agility. And that's not agile, that's agile little a, not the framework. You just need to be able to move quickly. To break that down a bit more, kind of awareness. So obviously this is a New Relic event. Neil's obviously been through all of the metrics and the metadata that we can collect and how you manage that data and how you can trend and train an AI to consume that data and be able to correlate events, so that you can, in the event of an outage, you can say, look, this isn't available, but why not have a look at another one of our product lines? Okay, and then not just awareness of your application. So again, relating back to that hug of death, if you're on the front page of Reddit or you're on Hacker News, it's the awareness of the wider world. Now, there was a guy I heard about who was a day trader, and he realized that if he could collect Twitter tweets from Donald Trump, he could correlate that if Trump mentioned a company, the stock would wildly deviate in one way or the other. So if it was obviously a positive statement from Trump, maybe the stock would go down, or the opposite might be true. And he was able then to buy the stock in that company or sell the stock, depending on what Twitter was saying or what Trump was saying on Twitter about that particular company. So having that awareness of what the world is saying and what the world is doing can often impact and is a valuable metric to how you operate your service. Okay, obviously then availability, we're talking 99.9% uptime for an application. If you're not correctly prepared, if it's not correctly designed, so the architecture isn't designed efficiently enough, 99.9% may correlate to quite a big number if you start scaling up to Amazon size or to the sort of traffic that Amazon.com are seeing. If you have 1 million servers, that becomes a problem. That 0.1%. Yeah, 0.01%. Obviously, your response times, a big thing around certainly millennials. Google did a survey, and they said that 53% of mobile visitors abandoned their search after 3 seconds because it didn't load quick enough. Because the content you want your customers to see just wasn't there in their time span. And then there's obviously global localization. So you want to be able to serve your customers with local information. You know, if you're serving people in France, you want to have the ability to translate into French. The same as anywhere in the world, if it's America or if it's in Asia. And that sort of globalization kind of feeds into some new technologies and some new concepts that are coming around sort of edge computing that we'll talk about a little later on. And like I said, agility, this is moving fast, not the agile framework. You don't just adopt agile and then become successful. You need to be able to move fast, innovate fast. This is having tight feedback loops. If you're doing kind of agile and DevOps, you need to be able to understand what your customer is wanting, desiring, and ultimately what they need, right? And then give it to them quickly. Okay. So again, my role at ECS Digital is container lead. So a lot of my focus day to day is kind of how to migrate people from VMs to containers, how we're going to be doing a cloud strategy with Kubernetes, how are we going to be able to move monolithic legacy workloads into containers and then eventually into the cloud. So these are the kind of the success factors that I believe, and certainly my team believes, are important when you're looking to scale. So these are the things to focus on really when re-architecting or re-engineering. So you've got your application, you've got some sort of container lifecycle, and if you're not a fan of containers, then you may be able to take this out and put in some sort of legacy application. And then obviously there's a cloud. As much as people are maybe afraid of the cloud, or they just say, oh, it's just running on someone else's computer, so why should I do it? It is coming, and it is here, really. There are companies that have abandoned their own data centers and just moved solely to the cloud. So you need to be designing and building your applications that are cloud ready. Okay, so one thing we follow, certainly I follow when I'm kind of talking to my customers, is the 12 factors of building an application. And these are some of the things you need to consider. You build your application to have clean contracts. So this is using APIs. Your function or your API or your microservice, however you want to describe it, it doesn't care about its third-party dependencies. It does its job, and it does its job well. And once you have the small components that can do that, you can then start putting them together, building them up into a useful application that actually serves content to your customers that is what they want and desire. So obviously stable development, that's talking about I don't really develop anything. I'm not a front-end developer, but when I do touch front-end or I do any kind of middleware implementations, or I'm looking at developing some custom middleware for a customer, I'm doing it in Docker. I'm building a container because that's the easiest way for any system to consume a new piece of technology. I don't want to be downloading zip files and running through installation guides. I want to do Docker pull and then Docker run and have my application running. I want a demo that runs solely inside a container, so I can say, look, this is how it works, this is how it's built, this is how you can use it to leverage your services, and can the whole thing when I'm done and move on. And it's that ability to kind of spin up what you want inside containers and build a workflow that works not only in development, but can be replicated then into production. And then obviously, there's more information then on kind of how 12 factors work and how your developers really have to change the way they think about data and how your applications are working. And it really does help when we go in to kind of containerize applications that they've already thought about this up front. Obviously, really important if you're going to be doing containers and kind of cloud migrations, and you're working in kind of the modern application space is declarative automation, right? So this is Ansible, this is Puppet, this is your Travis files or your Jenkins files. You want your developers to be able to pull a code base, pull from Git, pull from Bitbucket, pull from GitLab, and it contain everything they need to build, run, test, and ship it. They don't want to be communicating with other teams unnecessarily to find out, how do I get this into production? It's the same process, right? You build it locally on your machine, and that is exactly the same process that we do into production. This gives you, the ability to be flexible. So when those peak loads hit, you can, instead of traditionally where you'd scale up to scale up vertically, you have peak load, make a bigger machine, right? More memory, more RAM, more storage. Instead, we can go horizontally because we have a repeatable process for deploying these applications. We can go end tier on an individual host, and then we can provision automatically because we have this. This automation is not just for your application, but it's also your infrastructure, and we can scale your infrastructure horizontally as well. And then it's that that makes it portable. You can onboard a development team a lot faster, and you can innovate, your services and increase your feature library a lot faster. So I've talked a lot about containers, and I've purposely not put anything up around Kubernetes or Docker Swarm or Mesosphere. It's really about the concept. When you're having these conversations with customers about how they migrate to the cloud and how they get to containers, that obviously orchestration is always in the back of the mind. Building with containers, obviously builds in complexity. There's things you have to do with secret management, network management, volumes that just traditionally maybe wasn't an issue, but in the new world, it's something you really have to consider and manage well. So the concept of orchestration is really key, and then really once you understand that, everybody who provides orchestration really does the same thing. It's just with a different color logo and different CLI. So we're talking secure software delivery development lifecycle. So this is being able to produce those containers, being able to store them centrally, test them with policies that your organization has defined, and being able to use basically the same thing in development as in production. So you avoid it works on my machine. Okay, so federated clusters and located near the users. This is getting into where when you start building at scale, you have to think about your global customers, right? If you're delivering to people all over the world, there are lots of different laws that govern different countries. And having a cluster or an endpoint or an environment that sits within different sovereigns means that you can maintain data integrity, data security, but obviously you need somewhere to control that and manage those centrally. So the federated model is having something like Kubernetes or Docker Swarm in each of the countries, and then you have a centralized management interface inside your organization that can have a light touch on what happens. So you define the policies, you define who has access, but the data stays where it should be, and it never leaves that country. That obviously makes you highly available. You can fail over to other regions if necessary, as long as that data integrity is maintained. And having a federated model, in order to get to that point, you will have to be able to automate the deployment of these things. So you can't send guys out all over the world to stand these environments up and then have them report back with, this is how you connect to it. You really want to be able to, from a centralized location, deploy out to the wider world. So you can have reactive platforms really that scale independently. If you've got if you've got a lot of load in Russia, or you've got a lot of load in China, you can scale that up without scaling up your domestic environments. And then obviously the cloud. Obviously we're talking, with those federated models, we are talking managed services. Now, in my opinion, I've stood Kubernetes up, I've stood Docker Swarm up in enterprises, and it's difficult. And it's not difficult because I'm underqualified or the people I'm working with don't know what they're doing. It's because the tool is very complex. And in order to do it effectively, you have to invest heavily in that tool, training the people, making sure that your app's super secure and you've got the connectivity that you need into wherever you're deploying. So certainly managed services is not something to shy away from. If you can have support contracts and dedicated SLAs to fix any issues that you're having, certainly go with your managed service. 2 weeks ago at DockerCon, announced a tech demo where you're now able to manage any managed service Kubernetes from within Docker Enterprise. So you stand up your Docker Enterprise domestically, maybe inside your data center or inside your cloud provider at home, and you can then deploy
managed services and on-prem. Now, once we move kind of beyond the cloud, so we're looking really at 5-10 years in the future when everybody's using containers in the cloud and it's a standard, really what's the next step? So, the ability to outscale your peak load is really built on the foundation of being in a containerized environment in the cloud. But how do we move away from having to use, somebody else's computer? Now, one way of doing this is using serverless. So this is breaking your application or your microservice down even further, so that your application is comprised of a number of independent APIs, and you can stitch them together with a mesh and create a serverless application. So deploying only the application itself onto abstracted infrastructure. And then, of course, if you're a fan of kind of cryptocurrency or any kind of blockchain technology, you may have come across DApps. So these are distributed applications, and this is really serverless 2.0. This is the ability to deploy an application that lives on a distributed network and has no single point of failure and has no single entity looking after it. It's just replicated across the entire infrastructure. So that's really the kind of next steps. But we're, like I say, we're a few years away from having serverless everywhere, and certainly many years away from having distributed applications. So just to conclude, when considering building infrastructure and applications that can outscale peak load, we must consider our application design. This is creating applications that are preferably stateless and that can be deployed and replicated without interfering with the day-to-day running of the application. Now, moving to containers, so containerizing your applications is a surefire way to give you consistency, portability, and added security. And once your application is containerized, this will accelerate your migration to the cloud, as you have a single standardized shippable product that you can move into any of the infrastructure that we've described.